Alright, this is the second part of your notes for section 4.6, and it's on equilateral triangles. Remember, 4.6 had two different types of triangles it talked about. Isosceles, which was your first video, and the second video deals with equilateral. Now, I will warn you, equilateral triangles are a lot easier. There's only a couple things you can do. You can't really get it wrong. There's just two things you have to remember, okay? So, equilateral triangle, these are some vocab words we're going to recap. Means all sides are equal or congruent. And that's how we get the name. Equa means equal, lateral means distance, all the sides are an equal distance. Okay, equiangular triangle means all angles are congruent. And we talked about this in an earlier video. If there's 180 degrees in a triangle, all three of the angles have to be the same. We would divide by 3, which means each angle is 60 degrees. Okay, so anytime you see a triangle with 3 angles that are all marked 60, you automatically know it's equiangular. Okay? Now the big idea we're going to talk about, and I've told you this before, I told you this in your 4.1 video, equilateral triangles are also equiangular. Okay, they go hand in hand. If I have an equilateral, then I have to have an equiangular. If I know it's equiangular, then it has to be equilateral. They always need to go together. So if we're going to mark our picture, an equilateral triangle would have all the sides marked, and then all of our angles would need to be marked. And each one of those angles is 60 degrees. So that's what our picture would look like. Now, when we're solving problems like this, if they give you an angle, an expression, you know it has to be 60 if it's equilateral or equiangular. So you can set whatever that expression is to 60. That's your go-to, okay? Now, they're also congruent, so you could set them equal to each other, and I'll give you a little recap at the end. And we're going to do an example, and we'll touch on all these things. But most of the time, things are either going to be set equal to 60 if it's an angle, or they're going to be set equal to each other if they're congruent, or if we're talking about the sides, okay? So let's look at our example. Our example says determine the values of x and y. Notice we've got two different ideas going here. Our x's deal with the sides of our triangle, and the y deals with an angle. This is really important. You have to identify what the variable is talking about so that you can set the problem up correctly. For sides of an equilateral triangle, they're going to be congruent, and we've learned that congruent things can always be set equal to each other. So we'll say 4x minus 3 equals 7x minus 6. Okay? Again, they get set equal because the sides are congruent. Congruent means they're the same. They have to be the same distance, so they have to be equal to each other. Okay? Now we solve it like we normally would. Let's subtract 4x. Because this negative 3 equals 3x minus 6. Add 6 to both sides. So 3 equals 3x. Divide by 3. X is 1. Now, we're finished with that problem. Again, it doesn't ask us for the side length. We could plug it in and check and see if we got it right, that our sides would be equal, but it only asks us to find x, so we can stop there. We don't need to plug it back in. That's to find x. To find y, y deals with an angle. Since it's one angle of an equilateral triangle, equilateral, the angles are 60 degrees because it's also equiangular. So we can take 7y plus 4 and set it equal to 60. Now, again, we do that because all of the angles in an equilateral triangle have to be the same. They all have to be 60. So if I know that this angle here is 7y plus 4, it also has to be 60. Those two things need to be equal. So now we subtract 4. 7y equals 60 minus 4 is 56. Divide by 7. So y is 8. And again, we don't have to plug it back in. We can plug it back in to check. We should get 60 because the angles of an equilateral, equiangular triangle are always 60. We should plug that in and get 60, but it just asks for what the variable is. It just asks us to find y, so we can stop there. All right, now that's an example that combines both the sides and the angles, and that's what your homework will be like. You'll have several of those questions on your homework. So as a reminder, a couple reminders here. Always know, I'm going to say what you're dealing with. Okay, that's the big idea. If it's an equilateral triangle, sides, they get set equal. Okay, so you have to identify what the expressions are, what they're labeling. If they're the sides, you can set them equal. If you're dealing with angles, then two things could happen. If you have two angles that are marked congruent, you could set them equal. Okay, that is a possibility, and we didn't do that in our example. Or you can set to 60 degrees. Okay, because angles all have to be equals to 60 in an equilateral triangle. Okay, so two different ideas for angles, one idea for sides. So know what you're dealing with, identify what your expressions are labeling, and go from there. And that's really the only two things you can do for an equilateral triangle. You can set them equal, or you can set it equal to 60. So there's not really getting any confused if you know what you're dealing with. Okay? Those are your notes for section 4.6 on equilateral triangles. If you have any questions, rewatch the video, see if anything gets cleared up. If not, bring your questions to class next time.